Okay, thank you. Right, hello everyone. Thank you for being patient. So I'm going to carry on from Maris's tutorial, and I believe he got up to the collection of pickups. I'm not sure if he finished that. Could you fill me in on where you got up to? Mm-hmm. Okay, so let's take a look at that. We'll go to the prefabs, and we can see that we have a coin prefab. Now, when you're editing a prefab, what you have to make sure is you're actually editing the prefab game object and not an instance of the prefab. So the difference of that is if I drag these coins into the scene, then I have two instances of the coin, but the prefab is here, it's not actually in the scene. So what you want to do is you want to make sure that you edit the coin prefab and not the instance. So what is the difference? So let's see if I've got this coin here. Let's say I change the color of it, and this will hopefully. No, it's not going to change it. Let's just disable the renderer. So this renderer is gone. You can't see it. If I drag the coin in, then you're still seeing the image, but if I apply the changes of this prefab instance, it's going to apply it to every other instance. So this is going to update the prefab itself, and then you can see all the other instances change. So that's what the apply button does. So if what you want to make sure is, if you have like prefabs placed out in the scene, you need to edit a new instance of the prefab, drag it in the scene, then edit it, then apply your changes, then save, and then that's how you update every prefab instance. Okay, so there's this pickup script here. Let's go into Visual Studio. Not sure why it's taking so long. I don't actually know what that script is. I'm just opening it for the first time. We'll just take a look at it. It might have been a coin that was already a script that was already existing. Okay. So what we can see in this collect pickup script is when the game starts, this method is called start, and then it does this game object find method. So it's looking for a game object with the tag game manager, and then it's getting the game manager script. So let's just check to see. Yes, so here's the game manager script and here's the tag. So it should be able to find this object when the game starts, then in the 2D trigger enter method, so this gets called when another collider enters the 2D collider of this coin. So this 2D box collider, and then the code in here runs. But here it's checking to see if this other game object is tagged as the player. So like you wouldn't want it to run, say, if like the coin was inside a block, for instance. So it's good to also check here. So let's just see if this does what we expect it to do. Let's move the coin down here. Let's get the player here. Yep. So you could see that it did indeed destroy the game object and run into here. So like, let's look at the player. We know it works, but I just want to double check. So that here the tag is player, but if we untag this, then we will see that the coin will no longer be collected. So if you're trying to get a collision to work and it's not working, chances are it's because it's not detecting that it should collide. Okay, let's look at this game manager method. So if you're not familiar with Visual Studio, what you can do is mouse over the functions to receive more information about it. The Unity methods, they have a little bit of information about what the function does, but your own methods, they don't. That is, unless I'm going to go to the definition by right-clicking. You can give information, which is useful if you're working with another person. If you... Oh no, UK keyboard, Norwegian keyboard. So if you do // Visual Studio will create this comment summary, and then you can type in what the function does. So this increments the score counter, and then it should do that. Maybe it needs to recompile. Oh. Okay, well, this increments the score counter here when it comes in. But what if we want to add more things to this? What would be a logical thing that this game needs to be more engaging? Unless you think it's exciting enough as it is. Boss battles? Maybe just some normal enemies? Enemies. We'll start with enemies and then we'll get to the boss battle. Okay, so I've noticed that there was a character here. It's not actually set up with a sprite sheet animation yet, but that can be done later. So let's drag him into the scene so we can work with him. It's a bit on the small side though. Let's make him bigger. And let's get rid of this coin. I've just changed the instance of the prefab. So if I wanted to update the prefab, I'd click here. You can see when there's values that are different on the instance because they go bold here. So you can see that this text is bold because it's different. And if I press apply, then you can see that the scale is no longer bold. Yep. So let's make him do stuff. Let's add components, and let's call him enemy controller. Sometimes Unity will want you to reload the solution, so if it's not really doing anything, just double click Visual Studio and make sure that it's everything's imported. And it has a habit of, when it reloads, it doesn't actually open up the file that you want, so it's slightly annoying. Okay, so here we have the initialization method and we have the update. What would make a lot of sense is if we also stored a reference to the game manager. That might come in handy. So we can just copy this startup method. The game manager is basically responsible for keeping track of what's happening in the game, because the enemies and the coins will disappear. They'll be destroyed and removed from the scene, but the game manager can like keep the score, for instance. So at the moment, I think the game manager is just being used for counting how many coins have been collected, but you might want to put more things into that later, so we can have some fun with that later, and then there'll be an exercise tomorrow where we'll try and make this game a bit more exciting and a bit more unique to people's tastes. Okay, so update method. This is called once per frame. So there can be many frames over a second. So normally what you will see if you're playing a console game is it's fixed to 60 FPS, and that's to do with how quickly your screens can update. So usually games run at 60 frames a second, or they're clamped to 30 frames per second, which is the next increment down. So here what we want to do is probably want to make the enemy run towards you. So we can get there's two ways to make game objects move. One is by setting the position directly. So on the transform, there's a 3D vector position of where it is in 3D space. In this case it's actually like 2D space, but we'll just ignore the Z axis, which is forward into the scene. And what we want to do is we just want to move this position every frame. So let's take the current X position, current Y position, and why not the current Z position. And then we want to update it by speed. What would be handy is if we had like a constant speed that it moved, say like in meters. Let's say the speed is 10 meters per second. But then, since this is called multiple times a frame, let's make sure that we multiply the speed by how much of a second has passed since the last frame. So that would be the change in time, so delta time. And you notice that this is getting rather long, and that's a little bit hard to read, so a little bit of the programming trick is to, every time there's a comma, you just press enter. It's just a small style thing that programmers do, and then it's a little bit easier to read. Okay, so let's see if he moves. So here, he did indeed move, but he just shot straight off the screen because this is just setting his position in 3D space. We're not actually moving him as if he was a physics object. So I'm not sure if Marius has gone over with you what Unity's physics system is. Hands up, who knows what rigid bodies are? Some people, cool. So the rigid body system is Unity's physics simulation. So Unity basically simulates how things work in the real world and puts it into the game. The 2D physics system only works in 2 dimensions, as you would imagine. It only works in X and Y. And so what's happening is when we set the position ourselves, we're actually like overriding the physics system and ignoring it. So we don't actually want to do this. So I'm just going to comment it out. Let's move it a different way. Let's get the rigid body component instead. We'll just get that at the start, so we're only getting it once rather than every frame. And then we want to do something with this. So there are 2 types of methods of how rigid body works. Oh, actually, there's 3 now. So kinematic. When you have rigid bodies, whether they're 2D rigid bodies or 3D rigid bodies, kinematics basically means that you calculate it yourself. So if you select kinematics, Unity will basically like stop handling like forces, and you're supposed to move it yourself. Whereas if you have it as dynamic, then it's applying forces in the simulation. So like torque, which would be the rotation force. We just want to add a force in 2 dimensions. So a new vector. And this is pushing against the object. So if you want to push it left, then we want to, if you can imagine like an arrow, like a wind or a windsock pushing against you. That's what this vector is doing. So let's take the speed and the time, and we'll just push him left. And we'll take speed down a little bit as well because it was a bit fast. This is going a bit too quickly. Is there a way we can slow this down? Yep, let's just slow it down. I'm terrible at this game. So he's not actually moving, but my desk is. So let's increase the speed. So what are the methods we have? Price force components in the X and Y axis. He is not moving. Maybe what I want to do. He does not want to. He does not want to move, does he? What am I doing wrong here?
Does he have a rigid body?
He does have a rigid body.
Box glider is X.
As you can see, I've just turned up and I haven't gone through the tutorial myself, because really it shouldn't be too difficult. I'm probably just forgetting to do something. Maybe the force is just way too small. What? Rotation. So what is different? Extra points if anyone works this out before me. Fixed update. Yeah. You can give that a go. Let's look at the. I mean, it shouldn't really. matter if we're doing delta time. Like if you do it in fixed update, then you wouldn't have delta time, for instance. We'll work it out. Character move. Let's see what this method's doing. Physics 2D overlap circle. Rigid body velocity. Okay, so it's setting the velocity directly rather than applying a force. And then movement is. Here it's got a tertiary operator. So some of you might not be too familiar with this. Basically, this is just like an if-else statement written in an old syntactical way. But yes, it wants to just set the velocity, and for some reason the forces is not working properly in the update loop. Okay. Okay, let's go back to the character. Let's put it back to dynamic. Joy. This does not multiply by delta time. Vertical speed, ground speed. Alright, let's try fixed update. So in the difference between update and fixed update is the update loop runs irregularly between frames, whereas fixed update, it waits for it to run in fixed intervals. Let's go here, change it to fixed update, and because it runs at fixed intervals, we don't need delta time. Okay, it was because the simulate button was disabled. That was the reason. So we can turn the speed down. The mystery is then solved. Cool. So now we have our enemy working and we know he goes left. What we can do is we can apply that change, and then we have enemies that we can like spawn. But if we were looking at the way the coins spawn, which Marius set up last time, he's using these spawners at the edge of the scene. What problems would that cause if we just randomly spawned enemies? Yeah. Any ideas about what enemy spawning system we should have? How should enemies spawn in the platformer?
Initialize a position. In the start method. Initializing the position somewhere when he doesn't spawn.
Right. Yeah. Because you'd want him to always spawn over land. So I think I can think of two ways we could approach this. What we could do is we could have a game where we have a spawner at the top of the screen here, and then we check to see if there's a platform below us, and we try and drop him on there. That's one way that you could do it, which would be a valid way. Another method, which I think is a slightly better method, but a little bit more complicated, is if we look at the prefabs for the platforms themselves, and then we edit the platforms so they have spawn points on them. I think that's probably a safer method to make sure they're always spawning there. So let's find our platforms. Platform long, platform medium. So we have grass here, grass here, grass here. I'm gonna put the spawner here at the back. So I'm going to add it as a child of this one at the back. So new 2D object. Let's just say it's a sprites. And then what do we have for the spawners? Do they have? Ooh, they use white, so let's use that. That is a fairly big sprite. That's probably too big. Let's add a new script, and let's call it enemy spawner. Yeah, let's put to reload. Okay, so what I want to do is I want to spawn an instance of the enemy at runtime. So for convenience, I'm going to create a property, which is the enemy prefab. So I can just set that up in the inspector. Spawner, and then I'm going to get the character prefab, which I have put here. And then what I'm going to do is I'm going to set up a quick timer. Or should we set it up so the enemies spawn multiple times, or should we have them spawn only once when the platform begins? Any preference? Multiple times. Make it harder. Okay. Okay, so we're gonna have infinite enemies spawning from this platform. So let's set a time interval between enemy spawns. So let's say it's in seconds again. So enemy spawn interval, and let's say 0.5 seconds. Let's have some fun. That's going to be a lot of enemies, and we also need to set up a counter that's going to remember the value between frames. So we'll say enemy spawn counter, and that's going to start as 0. So I'm going to add the delta time, time since last frame, and then I'm going to check if the counter has passed the interval. So then a spawn is due. Now I'm going to reset the timer, and we're going to spawn game object instantiates enemy prefab. And that's just going to instantiate it like just in the game scene. It's not going to have a parent when it gets instantiated. Let's give this a go. This is slightly large, so let's make it a wee bit smaller. And we want it to be at the position of the end tile, so I'm just gonna get rid of this. How big are our tiles? So they are, well, this one is this size, 1.28. So let's set it to that. Maybe it's not. Let's just do it manually. Okay, let's put it up here. How big is the enemy? Yep. We just will make sure he is this big. So he should appear. Let's just disable this guy so we don't get confused. Okay. Yeah. And then I get pushed over. These are slightly fast characters, aren't they? So maybe we should reduce the speed a little bit more. And it was a little bit excessive. Also, what was happening was you notice the enemies were just pushing the character back. They weren't hurting the character in any way. So what we're going to have to do is we're going to need to get the collision of when the enemy runs into the player, so the player can actually lose, so they're actually a threat. So I know I've just removed the character, but we're going to have to bring him back again. Come on, Unity. Not sure why. Getting that enemy. Okay. Let's go get our character. So we have him, and he has a 2D box collider, and our player, he has a 2D box collider. But I think neither of these have a non-triggered enter callback. We'll just take a quick look. No. Coin pickup does though, so it's this method that we want on trigger 2D enter. So either we could put this on the player script, or we could put this on the enemy script. I'm going to put it on the enemy, just because there's a lot of stuff already in the player prefab. So these accesses. This thing that says public, I'm not sure if you know what these are. If you see public, it basically means you can access it from any other script. If it's private, then you can only access it from within this script. So when this is public, this technically does mean that you can just call that from another function and say, yeah, it was totally triggered. So really it should be private. And we want to check, was this the player? And in that case, what we want to do is, it is the player, so we want to tell the player that he's been hit. So let's get the component of the player, and let's say platformer character 2D, and that's in a different namespace, I think. This is a Unity project. Are these all in? Yeah. This is in the Unity namespace. Do we want a break? Yeah, I'm just deciding where the function should be to say the player's lost the game. But yeah, we'll take a bit of a break because it's been a bit of a long coding session.
Quarter past, perhaps? 10 minutes, okay.
10 minutes. All right. I'm just going to upload to Git where we are, so you can download if you're interested. Okay, so back in a little bit, guys.